Hi, I'm Philip, and welcome to Chemistry Class Notes. So, on this video is past JAM chemistry questions for last year, 2022. So, I'm going to be answering 40 of past JAM questions, chemistry, of course. It's going to be in two parts. The first part will be 20 questions, and the second part will be the remaining 20 questions, making it 40 questions. So let's go straight to answering this question. All right, number one, the subatomic particles located in the nucleus of an atom are neutron and proton, proton and electron, proton and ions, neutron and electron. Without wasting much time, your answer is A. The nucleus of an atom is made up of proton and neutron, while the electron is located outside the nucleus. Question 2. How many neutrons are present in atoms with mass number and atomic number 37 and 17? So we are looking for the number of neutrons. We are given the mass number to be 37 and the atomic number to be 17. So we know that mass number is equal to proton plus neutron. So from the question, we know this, we have to find this. Remember, the number of proton is the same thing as the atomic number. Number of proton and atomic number are the same thing. So I'll just make N the standard formula. That will be M minus P. So mass number here is 37. Then the proton, which is the same thing as atomic number, is 17. When you do this, 37 minus 17, you get 20. So the answer is B. 3. In the reaction above, the most suitable catalyst is chromium 4 oxide, iron 3 oxide, copper 1 oxide, vanadium 5 oxide. So this reaction is one of the intermediate reaction in the production of sulfuric acid, and the catalyst used is vanadium 5 oxide. Number 4. The following non-metals form acidic oxides with oxygen except we have phosphorus, sulfur, carbon, and chlorine. So your answer here is carbon. So number 5, the sulfide that is commonly used in coating electric fluorescent tube is, we have iron 2 sulfide, we have tin 2 sulfide, we have zinc sulfide, and we have lead 2 sulfide. The answer is zinc sulfide. Alright, number 6. The impact nomenclature of the structure is, this is structure. They want you to name this structure. We have A, 3-chloro-3-metylbutane, B, 2,2-dichloro-3-metylbutane, C, 3-methyl-chlorobutane, and D, 2-chloro-2-metylbutane. That's number 6. So in this question, this under organic compound, naming of organic compound. So first of all, there are rules in naming organic compound, and the first rule there is that you have to find the longest continuous carbon chain, right? 1, 2, 3, 4. So this is the longest, right? So 4 carbon atoms. That is that's butane. Butane. And when numbering, normally you number from this. The smallest number is given to the side that has a subsequent group. All these groups are subsequent group. So if I want to number, I should not start from here. 1, 2, 3, 4, because I'm giving the lowest number to where there is a subsequent group. So I have to start from here. I'll put here 1, 2, 3, and 4. So remember there are rules. So in naming, on position 2, we have this group here: chlorine, chloro group, and methyl group. So when naming, you name like this. There's 2 chloro, 2 methyl, butane. There's a rule that when there are 2 subsequent groups on a carbon atom, the one you mention first is the one whose alphabet comes first. That's where C, chloro, which is C, comes before methyl, which is M. That's why chloro came first, even though both of them are on the same carbon atom. So your answer is D. 2 chloro, 2 methyl, butane. 1, 2, 3, 4 is butane. So that is the laws for naming organic compound. Although I might want to do a video on that if I see the response. So I might just do a video on naming organic compounds. So just know your answer is D. Number 7. In the preparation of salts, the method employed will depend on the valve composition, dissociating ability, stability to heat, precipitating ability. So your answer is stability to heat in preparation of salt. 8. A chemical widely used as a fertilizer is, you have galena, bauxite, emerald, and nitro chalk. So your answer is nitro chalk. It's also used as a fertilizer. In fact, it's calcium ammonium nitrate. That is nitro chalk. It's used as fertilizer. So your answer is D. On the basis of the electrochemical series, which of these ions will show greater tendency to be discharged at the cathode in an electrolytic cell? Okay, this is a chemical series. So to answer this question, you focus on the one that is easily discharged. When you are going down, the one that is easily discharged, but going up is less is difficult to be discharged because they are more reactive. So those going up are so I just continued from zinc. I just continued like that. Otherwise, I would have written everything under. So just know that the further down the group, the further down the series you go, the easier it is to be discharged. And from what we are given here, you look for the one that is further down. If you watch, this iron, zinc is here, tin is here. So the next one is copper. Look at where copper is. Copper is here. So the one that's further down that has the greater tendency to be discharged at the cathode. So once you know the electrochemical series, you can easily answer such question. So your answer is copper because it is further down. The more they are further up, the less they tend to be discharged because they are more reactive. So your answer is copper. Why? Because it is further down the series. Look at the position of copper, but the rest, tin is here, iron is here, and zinc is here. The answer is A, copper. Number 10. An organic compound which liberates carbon dioxide from triazocarbonate 4 solution is. Remember, one characteristic of acid is that when they react with triazocarbonate 4 solution, they liberate carbon dioxide. So in the option, you have to look for the one that is an acid. Because when an acid reacts with triazocarbonate 4 solution, it will liberate or give off carbon dioxide. So from this option now, just find the one that is an acid. This is not an acid, this is not an acid, this is not an acid, this is an acid, this is eternal acid. So your answer is D. Without wasting time. 11. Addition of charcoal to the filter bed of sand during water treatment for township supply is to prevent goiter, prevent tooth decay, remove odor, key germs. Okay, the answer is to remove odor. To kill germs, they use chlorine. To prevent goiter, iodine. Prevent tooth decay, fluorine. So the reason why they're adding charcoal, right, is to remove odor. So your answer is C. 12. An organic compound with fishy smell is likely to have a general formula. We have this. Okay, actually, when you see something like this, fishy smells, we're talking about amines. amines, amines, and this is their formula. Arrow, that is a general formula. Arrow NH2. They are called amines. This smell. Addition of sodium chloride to water to form a solution would lead to increase in freezing point and increase in boiling point, increase in freezing point and decrease in boiling point, decrease in freezing point and decrease in boiling point, decrease in freezing point and increase in boiling point. Number 13. So your answer to this question is D. You notice that when you, practical example, when you have ice block, and you put salt in your house, you put salt on it, you notice that it decreases the freezing point. Also, if you put salt in the water and you're boiling it, of course, you don't expect, when it gets to 100 degrees centigrade, you don't expect it to boil at that temperature. Because of that salt you added, it's doing more work in the sense that the boiling point will increase. So it will boil after 100 degrees centigrade. So that's why your answer is D. Decrease in freezing point and increase in boiling point. Number 14. Look at this equation. What happens to zinc in the above reaction? 1. Oxidized, a reactant, reduced, a metal. Of course, this is a redox reaction. So it's either it is oxidized or reduced, right? So zinc, the oxidation state of zinc here is 0, but here it is 2. So increase in oxidation number, right? That is oxidized or oxidation. Increase in oxidation number is oxidation. Decrease in oxidation number is reduction. So we say that from this equation, zinc is oxidized in this equation because the oxidation number has changed from 0 here to 2. So your answer is A. Zinc is oxidized. Alright, number 14. An organic functional group which can likely decolorize ammonium silver nitrate is, we have alkene, alkyne, and alkanol. Without wasting much time, your answer is alkyne. Only an alkyne would decolorize ammonium silver nitrate. The others will not do that. In fact, this is one of the reactions to distinguish this and this, to distinguish an alkyne and an alkene and an alkyne. This can be used to distinguish this. Alright, number 16. Using the activity series, the method that can liberate hydrogen gas from steam is okay. This is activity series. This is not all of them. I decided to write from year to year. So, in activity series, those metals that can liberate hydrogen gas from steam is these guys. From magnesium to here, they liberate hydrogen gas from steam. Right? All these guys, they're very reactive. They don't need steam that much. But these ones, they're not too as reactive as this one, so they need steam before they can liberate hydrogen gas. So you check from these ones. Your answer is any of these people here. So if you watch lead, tin, copper, so it's iron. Iron is here. Iron is here. Alright? So all these guys, they liberate hydrogen from steam. So your answer is A, iron. A colored gas that is known to be poisonous and can readily damage the mucous lining of the lungs is hydrogen sulfide, carbon 2 oxide, chlorine, sulfur oxide. This question, you might not think much about this question. They said a colored gas, and in this question, it's only one gas that is colored. You get it? In this question, it's only one gas that is colored, which is chlorine. Most of us, we might not know the color of all the gases, but we must have heard something like greenish yellow gas. That is chlorine. It's only gas here that is colored. The rest, they are colorless. Get it? So your answer is chlorine. You might not need to look at the rest again. Of course, chlorine is a greenish, yellow gas, and it's poisonous. So your answer is chlorine. Number 18, look at this reversible reaction, right? From the reaction above, which of the conditions would produce the highest equilibrium yield for N2O4, which is this? We have A, low temperature and high pressure, B, high temperature and low pressure, C, low temperature and low pressure, and D, high temperature and high pressure. So remember, the conditions that will produce the highest equilibrium yield for this product here, not this one. So you're looking at this one. So we're looking at this. Since it is an remember, this is an exothermic reaction. For an exothermic reaction, if you increase the temperature, it favors the forward reaction, increasing the yield of this. If you reduce the temperature, it favors this side. So you are getting one for temperature. Remember, since it's an exothermic reaction, if you increase the temperature, it favors this side. If you reduce the temperature, it favors that side. So we are interested in this side, right? Because that's where this N2O4 is. So the first one is low temperature. That's one. Then for pressure, both of these two guys are gases, right? Pressure, works on, affects only gases. So for pressure, if the number of molecules, in one side is higher, in order to increase the yield, you reduce the pressure. While if the number of molecules in the other side is smaller, in order to increase the yield, you increase the temperature. What do I mean by number of molecules? Look at this is 2 NO2. The number of molecules here is 2, while this one is 1. So in order to increase the yield of this one, you have to increase the pressure for this side. If the question was about this one, we have to reduce the pressure. Why? Because of this number of molecules. If the number of molecules on one side is smaller, in order to increase the yield, you have to increase the pressure. While if the number of molecules on one side is higher, in order to increase the yield, you will reduce the pressure. So your answer will be low temperature and high pressure, which is A. Okay, an organic compound which decolorizes bromine water is likely to be. Okay, all these guys, the one that will decolorize bromine water is either an alkene or an alkyne. An alkane will not decolorize bromine water. So from what I'm saying here, all these guys, all these are alkanes. All these are alkane, single covalent bond. The answer will be this 18. So your answer will be D. D. This is an alkene. It is called ethane. This should dechlorize bromine water because of this double bond or unsaturation. A, B, and C, they are alkanes. They have only single bond, so they cannot decolorize bromine water. The ones that have double bond and triple bond can decolorize bromine water. So your answer is D, which is ethene. The last question for this first part of the video. An organic compound contains 69% carbon, 15.3% hydrogen, and 30.7% oxygen. Calculate the empirical formula. Okay, this one is just straightforward. So it's between carbon, hydrogen, oxygen. So we said carbon has 69%, 69. Hydrogen has 15.3. Oxygen is 30.7. So the next thing is you divide by the atomic masses. Carbon is 12, divide by 12. Hydrogen is 1, oxygen is 16. So when you do that, I'm getting 5.75. This one remains 15.3. Yeah, I'm getting 1.91. So from here, I'm going to divide. I'm dividing by the smallest. So which is the smallest here is 1.19. So I'm going to divide by this 1.91. So when I do this, I'm getting 3 here. I'll get 8 here. Of course, here will be 1. So that is C3H8O. I don't need to put 1 here because there's already 1. I don't need to put 1. So there's no need to put this 1. There's already 1. So your answer is D. Alright, so that's the end of the this video. The first part of the video. Chemistry Jam past question 2022. So the next video I'm going to answer the remaining 40 questions. It was the 40 questions I could lay my hands on. That's why I'm answering 40 questions. All right, so until next time, bye.